Gears are fundamental mechanical components used to transmit power and motion between rotating shafts. They enable control over speed, torque, and direction of motion in mechanical systems. Gears are widely used in automotive, manufacturing, power generation, and automation industries. So, here comes the important question. Why we need for different types of gears? As you know, mechanical systems operate under different speed, load, and space conditions. A single gear type cannot satisfy all operational requirements. Gear designs vary based on shaft orientation, load capacity, speed, and noise considerations. Now move on to the classification of gears. Generally, gears are classified into 3 types. First comes parallel shaft gears, which includes Spur Gear, Helical Gear, Herringbone Gear, internal gear. Second, intersecting shaft gears, which consist of Bevel Gear, Spiral Bevel Gear, Miter Gear. Last one is non-parallel and non-intersecting shaft gears, which includes Worm Gear, Poid Gear. Now let's discuss these types one by one. Spur Gear. Spur gears are straight-tooth gears designed for parallel shafts. These gears have a simple design and ensure high efficiency in power transmission. They are best suited for low to medium speed applications. Spur gears are economical, reliable, and easy to manufacture. These gears are known for producing more noise at higher speeds. Spur gears provide precise gear ratios, making them ideal where accuracy is important. These gears are commonly used in gearboxes, conveyors, and household appliances. Helical gear. Helical gears have teeth cut at an angle, which allows smoother and more gradual engagement. These gears are capable of carrying higher loads compared to spur gears. They operate with less noise and vibration due to the angled tooth design. Helical gears can be used for both parallel shafts and crossed shafts. These gears offer greater strength and durability, making them suitable for heavy-duty applications. Helical gears provide efficient and continuous power transmission. These gears are commonly used in automotive gearboxes, elevators, and compressors. Herringbone gear. Herringbone gears feature a double helical design with V-shaped teeth. These gears effectively cancel out the axial thrust produced by single helical gears. They provide exceptionally smooth and quiet operation even under heavy loads. Herringbone gears are designed for continuous and high-power transmission applications. These gears offer high efficiency and durability, making them ideal for demanding environments. These gears are commonly used in heavy machinery, marine propulsion systems, and industrial drives. Bevel gear. Bevel gears are used to transmit power between intersecting shafts. These gears typically change the shaft angle, most commonly at 90 degrees. They can have straight, spiral, or hypoid teeth, depending on the application. Bevel gears are highly effective for low-speed torque transmission. These gears allow smooth and efficient transfer of motion between shafts. Bevel gears are versatile and available in different designs for strength and durability. These gears are commonly used in differential drives, power plants, and hand drills. Spiral bevel gear. Spiral bevel gears are similar to bevel gears, but feature curved teeth for improved performance. These gears provide smoother and quieter operation compared to straight bevel gears. They are capable of transmitting high torque efficiently between intersecting shafts. Spiral bevel gears can handle higher speeds and loads due to gradual tooth engagement. These gears ensure stable motion with reduced vibration and noise levels. These gears are commonly used in automotive differentials, power tools, and industrial machinery. Miter gear. Miter gears are a special type of bevel gear designed with a 1-to-1 gear ratio. These gears have shafts that intersect, typically at a 90-degree angle. They have the same number of teeth on both gears, ensuring equal speed transmission. Miter gears are mainly used to change the direction of rotation without altering speed. These gears provide smooth and efficient power transfer in compact systems. These gears are commonly used in printing presses, conveyors, and packaging machines. Worm gear. Worm gears consist of a worm screw that meshes with a worm wheel. These gears provide very high torque reduction within compact spaces. They often have a self-locking feature, preventing the gear from backdriving in certain designs. These gears generally have lower efficiency due to higher friction losses. Worm gears are well suited for applications requiring precise speed reduction and compact design. These gears are commonly used in elevators, conveyors, and tuning instruments. Hypoid gear. Hypoid gears are a special type of spiral bevel gear with an offset shaft design. These gears allow smoother and quieter power transmission than conventional bevel gears. They provide large speed reductions within compact spaces. Hypoid gears are capable of handling heavy loads with high efficiency. These gears have sliding tooth contact, which enhances strength and durability. These gears are commonly used in rear axle drives of vehicles, conveyors, and industrial gearboxes. Rack and pinion. Rack and pinion is a gear system that converts rotational motion into linear motion. This system uses a pinion gear that meshes with a straight linear gear rack. Rack and pinion mechanisms are compact and easy to design. This system is commonly used for accurate steering and positioning control. Rack and pinion offers smooth operation with minimal backlash in well-designed systems. This system is widely applied in automotive steering, CNC machinery, and industrial automation. Planetary gear. Planetary gears system consists of three main components: a sun gear, planet gears, and a ring gear. These gears have a compact design that delivers high torque density. They can provide multiple gear ratios within a relatively small space. Planetary gear systems are known for precise and efficient power transmission. These gears distribute load across multiple gears, improving strength and durability. These gears are commonly used in automatic transmissions, robotics, and aerospace systems. Internal gear. Internal gears have their teeth cut on the inner surface of a cylindrical gear. These gears mesh with external gears, creating a compact and efficient design. They offer high load carrying capacity and smooth power transmission. Internal gears are ideal for applications where space is limited. These gears help achieve high gear reduction ratios in compact systems. These gears are widely used in pumps, automatic transmissions, and compact drive systems. Magnetic gear. Magnetic gears use magnetic fields instead of physical teeth to transmit torque. These gears enable non-contact power transmission, which greatly reduces mechanical wear. They provide natural overload protection as the magnetic coupling slips under excessive load. Magnetic gears offer quiet, smooth, and maintenance-free operation. Magnetic gears eliminate lubrication needs, making them suitable for sensitive environments. These gears are commonly used in aerospace systems, medical devices, and wind turbines.